We are building the top trumps project from the YByte Python curriculum available at www.ybyte.in. In the previous video, we saw how we could create a mapping dictionary, which allowed us to create an interface, which allows us to create an interface where our user will just specify the first letter of every key and will be able to make a choice. So we will move forward in this video and actually make the infrastructure to take the user's input as well as getting the computer to choose. So I come in back to my game here. I've been developing this game. Remember, once we display the player's card, I have now the, the next task is to pick up the choice from either the player or the computer. The player's card will be displayed regardless because that is always visible to the player. However, once that is done, I ask myself a question. Well, if chance is, let's say, player, remember that means the player's chance. Now, if this is the case, we've got to ask the player what is the choice, which of the keys would the player like to, let's say, play. Now, I will do that by saying, well, let me use an input statement. So I say chosen key is, say, input, and I just say, what is your choice? Now, just to make it, let's say, a little bit easier for my player, remember the player is expected to answer from the mapping dictionary. So I just go and say H, F, let's say Y, B and T. Now this is not a very flexible code, obviously, because this works for this specific mapping dictionary. If your keys are different, your mapping dictionary will also look different. So ideally speaking, we should do this in a little bit more general manner where we could get the keys of all the keys of a mapping dictionary, convert that into a string of this sort and put it here. But for now this is fine. So we ask the player for the chosen key amongst all of these. And of course, once the player has played, then the chance automatically and inevitably goes to the computer. So I just go and say chance is, let's say, computer. On the other hand, let's say I come in here and I see the chance, let's say, is computer. Now, in this case, the player does not get to choose. However, the computer will make a choice. Now, clearly, computer also should be smart. For example, let's say computer gets a card of Burj Khalifa. One would think that the computer should choose H as that is most likely to win. However, for now, I'm keeping it very simple. For now, I'm making my computer, let's say, pick up these keys randomly. Now, clearly, this is an opportunity to improve this game. This is an avenue for, let's say, enhancing the project. These are bonus ideas. But for now, we'll keep it very simple. The important point that I do want to make, however, is that even in case of the computer, I want to pick up the keys as H, F, B, Y, B, or T. That's because I want to keep the code between the player and the computer quite harmonious. That keeps my code concise and easier to understand. So I just go and say, well, look, chosen key in this case would be, well, remember, I'm going to randomly pick up a key. I will convert all the keys of the mapping dictionary into a list. And then I'll just do a random choice. So I just go and say, well, that's random dot, let's say, choice. And what do I choose from? Well, convert all the keys of the mapping dictionary to a list. So mapping dot, let's say, keys. So this basically will choose a key at random. The important point is that the chosen key format has not changed. It was, let's say, one letter in case of player. It's going to be the same one letter in case of a computer. Of course, once the computer's chance is over, computer is chosen, the next chance will be that of the player. So I just go and say, well, let's say chance belongs to the player. But now, next question is, okay, having chosen, let's say, this key, which is for the user interface point of view, which is like H, F, Y, B, and T. How do I map it to an actual dictionary key, which corresponds to the actual cards that I'm playing with? Whose keys were, well, height, floors, years built, and so on and so forth. In fact, the infrastructure is already set up for that. I will just figure out the requested key. I'll call it the key, let's say, requested is given by, well, in fact, all I have to do is to look at the value corresponding to the chosen key in this dictionary called the mapping dict. So that's exactly what I'll do. That basically is mapping dictionary, let's say, chosen key. So this will translate from, let's say, H to height, F to floors, Y to year built, and so on. Very nice uses of the dictionaries. Having done this, I can in fact go and read what are the values for the player and the computer, because remember, player card is called player, that is a dictionary. computer card is called compute. That's also a dictionary. I can just go and say, well, value, let's say player is nothing but player and say key requested. The reason I can do this is because thanks to the mapping dictionary, now key requested is a key which is valid for the player card and likewise for the computer card. So I can just go and do, let's say value, say comput is given by say compute, that was the name of the card, and key. Now think through this quite carefully. It's quite nice, in fact, how we are using dictionaries to make our interface clean, but internally we are doing some kind of mapping again to be able to read these dictionaries in a correct manner. Now, having done this, let's display to our player and our let's say to the interface what we have chosen. So we can just put a few print statements here. We can just say print, let's say key request, say key requested is, well, it's nothing but, let's say the so key requested is comma, let's say key requested, and I can then write, well, what is the let's say the player's key requested as well as the computer's key requested. So I can just put, let's say player say comma key requested say is, and well, that is nothing but the value say player in the player key. And likewise, I can put the computer, what is the value for the computer for that particular key. We can see this working. Let's say I got, let's say Kingdom Center Riyadh. I think I could choose, let's say the years to time to build in this. So I choose T. It tells me, look, player time to build. First of all, it tells me key requested time to build. That is correct because T corresponded to time to build, through the mapping dictionary. I know that's the time to build. Then I went and probed these individual dictionaries, the player and computer, and it turns out, well, player time to display is time to build is say 3 years. That is indeed, I see that here, and computer time to build is 5 years. So that worked out for me. I do not here see the computer card, but in fact, we can show it as well if we are, for let's say for the sake of debugging and understanding, I can just go and say, well, display the card compute, and it will display it in exactly the same way as the player card. Turns out, notice the compute card time to build was indeed 5 years. So that's how it's working. Think through this a little bit. Very nice, very clean this interface, and we can move forward. It also tells us, gives us some information about what's going on, which metric has been chosen. Of course, in case of computer, the computer will randomly choose. But the important point you notice is that for both player and computer, the same key is used. And that's correct because in one case, player chooses, computer follows. In other case, computer chooses, the player. Now, before I wrap this up, let's just look at something a little exceptional. Let's say something unusual. What happens, let's say, if my player is not very careful and goes and chooses a key which is not present in the mapping dictionary at all. Let's say, just for the sake of illustration, say I go and choose a J. Well, clearly J is not a key. I am going to end up in an error. In fact, I end up with a key error because this mapping dictionary does not have a key called J. Now, I will leave this as a sort of food for thought for you. How can you make this program a little bit more robust so that it does not crash the way it did? How can I still keep going? By probably assigning at this point a random key to the player because he did not choose well. Also, just to make it a little bit more robust, we could, do things like chosen key dot, let's say, capitalize and let's say strip the spaces and so on. So that will make the game also a little bit more robust. So always good to think about these things. But I'll leave that as a food for thought for you. Happy to discuss. And obviously, this is also a great bonus idea. I hope you're enjoying this process of learning. This is how we learn Python, by building activities. Look at our website, www.ybyte.in. You will find that there are many such videos of this sort. Take care. Thank you so much. Bye-bye.